Hello, this is Dr. Rudabaugh, and I'm going to provide a quick tutorial here on the Sun Angle Lab. Just a quick intro. If you want to work with a partner on this lab, it could come in handy. You just have to let me know what other student you work with and put both your names on it. Only one student is required to submit it as long as the name of both students is on the lab. This lab really comes in two phases. The first part requires you to look at a group of cities and that are grouped by regions, and we'll talk about the regions here in a second. And you're going to be required to calculate the sun angle for those regions over the different 4 times of the year: summer, fall, winter, spring. And then after you graph the cities, you'll be required to do some short answer. The total lab then is you have 4 graphs that are worth 10 points, and 10 short answers are worth 10 points. Before you get started on the lab, it's important to note that you really should make sure you're familiar with understanding latitude and longitude, in particular latitude. We really need you to understand latitude specific to the equator being 0 degrees, the Tropic of Cancer being 23.5 degrees north, the Tropic of Capricorn being 23.5 degrees south, and the North Pole being 90 degrees north and the South Pole being 90 degrees south. Because lines of latitude and where you are north or south of the equator are very important for understanding sun angle relationships and concepts that we'll use to calculate the sun angles for specific cities. So make sure you watch this video. This video here is a little mathematical formula of how you actually learn to calculate the sun angle, and we'll do it fairly close to how they do it into here. But the key thing is if you know a given location's latitude, your north-south position, you could actually calculate for different seasons the actual sun angle you would be getting for that time of year. So I'm going to scroll down through the lab, and we're going to basically be working with 4 regions of latitudes. Cities near the equator, which are called the tropics. Cities near the Tropic of Cancer or Capricorn, called the subtropics. Cities that are halfway between the equator and the North Pole or South Pole, which is where we live, which are called the mid-latitudes. And then we have cities near the North and South Pole, which we are called polar latitudes. The key thing to remember is the sun's rays do migrate with the seasons, and the key to understanding how to calculate the sun angle, as it's demonstrated in this video, is we really need to know where the subsolar point is, which is where the sun strikes directly overhead. By definition, the summer solstice is when the sun strikes overhead at 23.5 degrees north. Fall equinox is when the sun strikes overhead directly at the equator at 0 degrees. The winter solstice is when it strikes at 23.5 degrees south, the Tropic of Capricorn, and then on the spring equinox, the sun's direct rays are over the equator. Now, I'm going to scroll down here, and one of the things I want to click on here is the actual list of the cities is on this link, and when you click on the link there, you will see a list of cities popping up, and you can see the cities here coming in. All you need to calculate for each one of these cities is you need to know the city's latitude. So Eagle, Alaska is there, and there's a location in Russia. And notice how on each city there is a label of what region that city is associated with. So these cities here are all associated with being fairly close to the Arctic Circle and near the North Pole at 90 degrees north. Then as you scroll down, you have tropical latitudes, which are all near the equator, and there's 3 or 4 cities there. And then we have cities that are in the mid-latitude, which are about halfway between the equator and the North Pole. And then you have cities that are pretty close to 23.5 degrees north or south, and these cities are in the subtropics, like New Orleans, Louisiana here, for example. You'll basically be graphing the sun angle and keeping all of the cities together that are in the same region and producing a line graph. Just so you'll know for analysis, this black line shows you how the temperatures change for this city, and in Peru near the equator, and you could see how near the equator, how the temperatures, you see that flat line there, that's sort of important. As you could see that near the equator, in particular here for Ocean Island, how almost every month of the year the temperatures are roughly about the same from January through December. And that'll be the key for us to understand is why are some cities like Ocean Island almost not changing at all, whereas some cities like Galesburg, Illinois have very dramatic changes from January through the summer months and back down through the winter months in December over a 12-month year. So I give you some examples of how you calculate the sun angle, and you calculate the sun angle very simply by taking where in the summer you take a formula of where the sun's rays on the summer solstice, which we know they're at 23.5 degrees north, and you take, for example, we're going to I show you in this example for a fictitious location at 15 degrees north. I walk you through how to calculate the difference between where the sun's rays are and where the city is at. You take that total angular difference, and then you take that difference and subtract it from 90. The key thing is generally the easier ones to do are when you do these fall and spring equinox, because you're dealing with zero. So the difference in fall between the equator and 15 degrees north and fall and spring is simply 15. So you would take 90 minus 15, and you would get a sun angle of 75 degrees. For this location of 15 degrees north, in the summer, on the summer solstice, these two sit where the sun's rays are at and where the city is at are in the same hemisphere. And when the city and the sun's direct rays are in the northern are both in the same hemisphere, you basically just take the smaller number from the larger one, and you then take and subtract the smaller number from the larger number, and you take that number subtracted from 90. So there's 8.5 degrees separating 23.5 degrees north from 15 degrees north, and you would just take 8.5 and subtract it from 90, and you would say, the sun angle at 15 degrees north would be 81.5. Whereas in wintertime, the sun's rays are in the southern hemisphere at 23.5 degrees south, and the city is at 15 degrees north. Now the sun's direct rays and the city's location is in the opposite hemispheres. When the sun's direct rays and the city are in opposite hemispheres, you add the two numbers together. In this example, you would get 38.5, and you would take it, subtract it from 90, and 90 minus 38.5 would give you a sun angle of 51.5 during the winter solstice. And I'll be sending you some more examples of how to do these tomorrow morning. But one of the things I wanted you to know is when you do these calculations, how you'll know you're doing them right is you should never get a sun angle greater than 90. A sun angle greater than 90 is impossible because that's the highest it can be. And you can have a negative sun angle, and a negative sun angle should only occur in the polar regions. And that would mean a negative sun angle at certain times of the year would mean the sun would never come up. So when you get to question 1, or when you get all these cities graphed for the sun angles, each city will have 4 sun angle calculations. So for Eagle, Alaska, you'll have a summer solstice, you'll have a fall equinox, and you will have a spring, you have fall equinox, winter solstice, and a spring equinox. You will write down those sun angles for each one of these cities, and then you will put them into a graph. So for my example, and I think I actually give you an example for the subtropical cities. So you could see New Orleans, Brisbane, Australia, and Burma. They all are in the subtropics. I actually give you a demo of what that graph will look like. So the first thing you'll start with is you'll open up a spreadsheet, and then once you open up the spreadsheet, you'll actually structure a graph that looks something like this with the name of the cities. Across the top, you'll actually have the seasons of the year, summer, fall, winter, spring, and then you'll fill in the sun angles that you calculated. If you actually send me these numbers, I'll actually verify you're doing them right. So if you do them over this weekend, or I can get you feedback to help you get this done and make sure you got the numbers right. Once you got the graph set up, then you highlight the cells and you go to the Insert menu. And under the Insert menu, you can click, there'll be a graph option. You pick the line graph option, and you pick the one in the second row, first one on the left. And once you get there, I tell you, you'll get a chart wizard pop up, and when you're done, once you click the line graph, you could pick a variety of different line graphs. I like the one in the top left because it actually already forces you to get a title and a label for your y-axis. So you could put your y-axis as sun angle in degrees, and the title of your graph for this graph would be sun angles for the polar or subtropical region. Your final step will be to produce a graph, and this is what your graph should look like when you get done, is you should have 4 regions, one for the tropics, one for the polar, one for the subtropics, and one for the mid-latitude. And what you end up looking at, as you can see here, is you've got 3 cities, and these lines actually show you how the sun angle is changing with degrees by season. Where the sun angle is coming at its highest, that's when you're getting your most direct sunlight. When the sun angle gets to its lowest, that's when a location is getting its weakest weakest solar radiation. So this tells us that Brisbane, Australia, and the other 2 cities must be in opposite hemispheres because their summer and winter sun angles are opposite. And this tells you that Burma is actually getting its warmest temperatures in what we would call winter, and it's getting its coldest temperatures when it is what we call summer in the northern hemisphere. Now, when you're done, you're actually done with the graphs. You should end up actually having down at the bottom, I actually start tabs at the very bottom, and I actually label them subtropics, poles, mid-latitude, and tropics. And I have actually 4. You actually will be sending me a spreadsheet with 4 different graphs, one for each region. So I hope that gives you a start on knowing how to do the lab. And again, I will be sending a lab or an email tomorrow, hopefully with some more instructions and some examples. But I hope this helps you at least get started on how to get this lab going with your calculations and where your data comes from for the graphs. Thank you.